They were born together, two planets orbiting the same star, made from the same cosmic dust. Earth and Venus, almost the same size, almost the same mass. But somehow, they became complete opposites. One is covered in oceans, forests, and clouds of water. The other is a world of fire, where metal melts and acid falls from the sky. Venus is Earth's twin, but an evil one. To understand what happened to it is to understand what could happen to us. This is the real story of Venus, a story of beauty, mystery, and catastrophe. Let's start with the numbers. Venus has a diameter of 12,104 kilometers, only 650 kilometers smaller than Earth. Its mass is 81.5% of Earth's mass. Its density is nearly identical, suggesting a similar internal structure: an iron core, a rocky mantle, and a thin crust. If you could place them side by side, you'd struggle to tell them apart by size alone. Both planets formed about 4.5 billion years ago from the same protoplanetary disk, a swirling cloud of gas and dust surrounding the young sun. As gravity pulled matter together, countless collisions built these worlds grain by grain, rock by rock. Both experienced the same violent early period, bombarded by asteroids and comets that delivered not just impacts, but also water and organic compounds. Yet despite these twin origins, there's one crucial difference: distance. Venus orbits at 108 million kilometers from the Sun. Earth orbits at 150 million kilometers. That gap of just 42 million kilometers, less than 30% closer, made all the difference between life and death. For thousands of years, humans have watched Venus light up the sky. To the ancients, it was the brightest star that rose before dawn and shone after sunset. The Sumerians saw it as Inanna, the goddess of love and war. The Greeks called it Phosphorus and Hesperus, the morning and evening stars, not realizing they were looking at the same celestial body. The Babylonians were among the first to recognize this truth. Their astronomers meticulously tracked Venus's movements, recording its appearances in clay tablets that still survive today. They noticed its 584-day cycle, the time it takes to return to the same position relative to Earth and the Sun. This cycle, called the synodic period, became crucial for their calendar systems. To the Romans, it became Venus, the goddess of beauty. The Maya civilization went even further, building entire calendars around its movements. They knew Venus so well, they could predict its position years in advance. To them, it was both a timekeeper and a god, a celestial ruler whose appearances signaled war or peace. Even without telescopes, our ancestors knew there was something special about this wandering light. It moved differently from the stars, tracing a gentle dance around the sun. It was Earth's celestial sister, shining like a jewel in the sky. When the first telescopes appeared in the early 1600s, scientists turned them toward Venus, expecting to find another Earth. Galileo Galilei was among the first to observe it, noting that Venus showed phases like the moon, crescent, half full, proving it orbited the Sun, not Earth. This observation was revolutionary, providing crucial evidence for the heliocentric model of the solar system. They saw a bright white globe covered in thick clouds. Those clouds hid the surface completely. No mountains, no oceans visible. The planet's albedo, the amount of sunlight it reflects, is about 0.76, making it the most reflective major body in the solar system. This high reflectivity is why Venus shines so brilliantly in our sky. Some imagined that under those clouds were tropical forests, warm seas, maybe even life. In the 19th and early 20th centuries, astronomers like Svante Arrhenius speculated that Venus was covered in swamps, similar to Earth's Carboniferous period. Science fiction writers of the era set their stories in Venusian jungles, inhabited by exotic creatures. For centuries, we dreamed that Venus was another version of our world, lush and full of mystery. But the truth was far stranger and far darker. The dream of Venus as a paradise began to fade in the 20th century. As technology advanced, so did our curiosity and our reach. In the 1960s, the United States and the Soviet Union began sending probes to explore the planets. Venus was one of the first targets. It was close, bright, and about the same size as Earth. Surely, it would be the easiest to study. But what they found shocked the world. The Soviet Venera missions were the first to reach Venus. One by one, they entered its thick atmosphere, and one by one, they were destroyed. Venera 1 lost contact. Venera 2 failed during flyby. Venera 3 crashed without returning data. Some melted, some were crushed before reaching the ground. The Soviets were essentially building spacecraft to survive conditions they didn't fully understand, designing for an unknown hell. Finally, in 1970, Venera 7 became the first spacecraft to land successfully on another planet and transmit data back to Earth for 23 minutes before succumbing to the heat. What it revealed was a nightmare. The surface temperature was nearly 475 degrees Celsius, hot enough to melt lead, zinc, and tin. The pressure was 90 times that of Earth's atmosphere, equivalent to being 900 meters under the ocean. And the air was full of carbon dioxide and clouds of sulfuric acid. There were no oceans, no forests, only a wasteland of rock and heat. Venus, it turned out, was not a tropical paradise. It was a furnace. NASA's Mariner 2, which flew by Venus in 1962, had already confirmed suspicious findings. Infrared readings showed that the entire planet was uniformly hot, day and night, pole to pole. There were no cooler regions, no temperate zones, no safe havens. Venus was not just warm. It was boiling. The truth was now clear. Venus was Earth's twin, but it had gone terribly wrong. Today, we know Venus as one of the most extreme places in the solar system. Its atmosphere is made of more than 96% carbon dioxide, the same gas that traps heat on Earth. The remaining 4% consists mainly of nitrogen, with trace amounts of sulfur dioxide, argon, water vapor, carbon monoxide, helium, and neon. But on Venus, the effect is absolute. Sunlight enters the atmosphere, heats the surface, and the thick blanket of CO prevents that heat from escaping. The result is a runaway greenhouse effect, a self-reinforcing loop that turned the planet into an inferno. The atmospheric pressure at the surface is 92 bars to 92 times Earth's sea level pressure. This is like standing under the weight of an entire ocean. The clouds above, between 45 and 70 kilometers in altitude, are filled with sulfuric acid droplets. These clouds are so thick that only about 10% of sunlight reaches the surface, yet it's still hot enough to glow dimly red. And while the surface barely moves, winds there are sluggish at just a few kilometers per hour. The upper atmosphere races around the planet at more than 300 kilometers per hour. This phenomenon, called superrotation, is one of Venus's great mysteries. The atmosphere completes one rotation around the planet in just 4 Earth days. even though the planet itself takes 243 Earth days to rotate once on its axis. Speaking of rotation, Venus has another peculiarity. It rotates backwards, retrograde, compared to most planets. While Earth spins counterclockwise when viewed from above the North Pole, Venus spins clockwise. Not only that, but it's the slowest rotation of any major planet. A single Venusian day, one rotation, takes 243 Earth days, while its year, one orbit around the Sun, takes only 225 Earth days. This means a day on Venus is longer than its year. Scientists believe this backward rotation might have resulted from a massive collision early in Venus's history, or from tidal effects from the Sun acting on its thick atmosphere over billions of years. The truth remains uncertain. The sky glows orange due to the scattering of light through the thick atmosphere. The ground is dark and cracked, composed of basaltic rock similar to Earth's volcanic regions. If you could stand there, you wouldn't last a second. Your body would be crushed, burned, and dissolved all at once. Yet, in its own terrible way, Venus is beautiful. Thick clouds reflect sunlight so strongly that from space, it shines brighter than anything except the moon. It is both dazzling and deadly, a warning disguised as a jewel. But how did this world so similar to Earth become such a hell? Scientists believe that billions of years ago, Venus might have had oceans. Computer models suggest that early Venus, when the sun was younger and fainter, could have maintained liquid water on its surface for as long as 2 billion years. It may have started with water, just like Earth did, delivered by comets and asteroids during the late heavy bombardment. But being closer to the sun, it received more heat, about 1.9 times the solar radiation that Earth receives. Gradually, those oceans began to evaporate. As water vapor rose into the air, it trapped more heat, which caused more evaporation. Water vapor is itself a potent greenhouse gas, creating a vicious cycle. The cycle spiraled out of control. Eventually, the oceans boiled away completely, without water to absorb carbon dioxide, a process that on Earth happens through rainfall, weathering of rocks, and the burial of carbonates in the ocean floor, the gas built up in the atmosphere. Volcanic eruptions added more CO. On Earth, plate tectonics continuously recycle carbon, pulling it down into the mantle and releasing it again through volcanoes, maintaining a balance. But Venus lacks plate tectonics. Its surface appears to be a single solid shell, preventing this recycling. Without this carbon regulation system, greenhouse gases accumulated unchecked. The surface grew hotter and hotter until it reached the deadly state we see today. The sun's radiation also played a destructive role. Without a protective magnetic field, Venus has none, likely because its slow rotation prevents the dynamo effect in its core. Solar wind and ultraviolet radiation split water molecules apart through a process called photodissociation. Hydrogen, being light, escaped into space. Oxygen remained, but reacted with rocks on the surface, forming oxides. What remained was a dry, suffocating planet, a greenhouse turned to stone. Venus became a living laboratory of what happens when climate change runs wild. A reminder that even a small shift in balance can transform a world forever. On Earth, greenhouse gases warm our planet too, but just a fraction of what happened on Venus. Our atmosphere contains only about 0.04% carbon dioxide, yet even small increases in this concentration cause measurable warming. Venus shows us the extreme endpoint of greenhouse warming. Studying Venus helps us understand how fragile our own climate truly is. Climate scientists use Venus as a test case for atmospheric models. If we can accurately model Venus's atmosphere, we can be more confident in our models of Earth's climate. The concept of the habitable zone, the region around a star where liquid water can exist, becomes more nuanced when we consider Venus. By distance alone, Venus sits near the inner edge of our Sun's habitable zone. Yet, it's clearly not habitable. This teaches us that location alone doesn't guarantee habitability. Atmospheric composition, volcanic activity, planetary rotation, magnetic fields, and even geological recycling systems all matter. In a way, Venus is not only Earth's twin, it's a warning from the future. If Earth's climate systems were to fail, if positive feedback loops were to spiral beyond our control, we could theoretically face a similar fate, though not on the same timescale or severity, given our greater distance from the Sun. Even after decades of study, Venus still holds secrets. Beneath its thick clouds, we've seen hints of volcanoes, and some may still be active today. The planet's surface features more than 1,600 major volcanoes and volcanic features, including vast plains of lava flows that cover about 85% of the surface. Recent observations have detected transient bright spots in infrared images, suggesting fresh lava flows. In 2020, scientists analyzing old data from the Magellan mission reported finding evidence that at least 37 volcanic structures had changed shape, consistent with recent eruptions. The European Space Agency's Venus Express mission detected variations in sulfur dioxide levels in the atmosphere, which could indicate active volcanism pumping fresh gases into the air. On Earth, sulfur dioxide spikes are a telltale sign of volcanic eruptions. Venus's surface also shows features called coronae, circular structures hundreds of kilometers across, created when hot plumes of rock rise from the mantle, dome the surface, and then collapse. These are unique to Venus and may still be forming today. Unlike Earth, where volcanic activity is concentrated along plate boundaries, Venus's volcanism appears to be distributed across the planet, driven by hotspots in the mantle. This suggests a different internal heat mechanism, possibly episodic resurfacing events where the entire planet's crust periodically overturns and renews itself. Crater counts suggest the current surface is relatively young, perhaps only 300 to 600 million years old, implying a catastrophic resurfacing event erased older features. In September 2020, astronomers found something even stranger: traces of a gas called phosphine in the upper atmosphere. The discovery was made using the James Clerk Maxwell Telescope and the Atacama Large Millimeter Array, detecting phosphine at about 20 parts per billion in the clouds at around 55 kilometers altitude. On Earth, phosphine is often produced by life, specifically by anaerobic bacteria in oxygen-poor environments like swamps and the guts of animals. It can also be produced industrially, but there's no industry on Venus. Geologically, phosphine can be created by volcanic activity or lightning, but calculations suggested these processes couldn't produce the amounts detected. Could there be microbes floating high above the clouds, where the temperatures are cooler? At around 50 to 60 kilometers altitude, Venus's atmosphere is surprisingly Earth-like. Temperatures range from 0 to 60 degrees Celsius, and pressure is about 1 bar, similar to sea level on Earth. Water exists as droplets in the clouds, though they're highly acidic. Still, some extremophile bacteria on Earth can survive in acidic environments. The discovery sparked debate around the world. Many scientists were skeptical. Some said it might be a chemical process we don't understand, or even an error in the observations. Follow-up studies have produced mixed results, with some unable to confirm the phosphine detection at the same levels. But the question remains, could something somehow survive in Venus's upper atmosphere? The idea may sound impossible, but so did life at the bottom of Earth's oceans, until we found it there, thriving near volcanic vents in complete darkness. Even if the phosphine turns out to have a non-biological explanation, it has refocused attention on astrobiology beyond Mars. Venus keeps reminding us that we don't know as much as we think we do. After years of focusing on Mars, humanity is finally going back to Venus. NASA is preparing 2 new missions, Veritas and Da Vinci Plus. Veritas, that is Venus emissivity, radioscience, NSAR, topography, and spectroscopy will map the surface with radar to study its mountains and volcanoes in detail, creating high-resolution topographic maps and looking for volcanic and tectonic activity. It will help us understand Venus's geological history and whether it still has active plate tectonics in any form. Da Vinci Plus, that is Deep Atmosphere Venus Investigation of Noble Gases. Chemistry and Imaging Plus will send a probe down through the clouds, measuring gases and pressure as it falls, giving us our first direct look at the atmosphere in decades. It will analyze the composition at different altitudes, looking for clues about the planet's history, including whether it once had oceans. Near the surface, it will take the first high-resolution images of Venus's unique tessera terrain, complex ridged areas that might be remnants of ancient continents. The European Space Agency will send Envision, a powerful orbiter, to study how Venus changed over time, using radar and spectrometers to examine the surface and atmosphere. Together, these missions will help answer the big questions. Did Venus ever have oceans? Was it ever habitable? And if so, when and why did it die? Private companies are also looking at Venus. Rocket Lab has proposed a small mission to search for organic chemistry in the clouds. Other concepts include floating habitats in the cooler upper atmosphere, where conditions are less hostile. For the first time in generations, Venus is back in the spotlight. Scientists call it a rebirth of Venus exploration, a second chance to understand the planet that mirrors our own fate. Venus is not just a story of disaster. It's a story of connection. From its birth in the same solar nursery as Earth, to its clouds that once might have carried rain, Venus has always been our sister. But she chose a different path, or rather physics chose it for her. Her oceans boiled away, her air turned toxic, her beauty became her curse, and in her reflection, we see what could happen if we lose balance on our own planet. Every world tells a part of our story. Mars shows atmospheric loss. Europa and Enceladus show life's possibilities. And Venus shows how thin the line is between paradise and inferno. Until new probes land on that glowing surface and finally learn how it all went wrong, Venus remains both a mystery and a message, a twin that was lost and a warning written in the clouds.